Hello and welcome to another video from our CBSE Class 10 revision program. This video is brought to you by Adams Academy, an expert online tutoring service for high school mathematics. This video is going to be a summary of the chapter Areas Related to Circles. Let's start with some basic concepts. We are all familiar with a circle. Let this be a circle of radius r. You know that the area of the circle is pi r squared, where pi is an irrational number, usually approximated to 22 by 7 or 3.14. The value of pi will usually be given in the question, and you also know that the circumference of a circle or the perimeter of the circle is given by 2 pi r. Now let's look at two special parts of a circle. The first is called a sector. As you can see in the figure, a sector is a region which is enclosed by two radii and the corresponding arc. So this region is called a sector, and a segment is the region which is enclosed between a chord of a circle. So here AB is a chord and the corresponding arc. So the region enclosed between a chord and the corresponding arc is called a segment of a circle. Also, you have heard about minor and major sectors. For example, in this figure, the shaded region is a minor sector and the remaining part of the circle is called a major sector. Similarly, for segments we have minor and major segments. Now let's try to find the area of a sector. Consider this circle with a sector OAPB, which is a minor sector. Now the angle of the sector is theta. You know that for a full circle the angle subtended at the center is 360 degrees and the area of a full circle is pi r squared. So using unitary method, for 1 degree the area is going to be pi r squared by 360, and for a sector with angle theta the area of the sector is going to be pi r squared by 360 into theta. You can also write this as theta by 360 into pi r squared. So that's the area of a sector. To find the area of this major sector, all you need to do is subtract the area of the minor sector from the area of the circle. So you can either do it like area of circle minus area of minor sector, or to find the area of the major sector directly, you can use the angle of the major sector. So we are talking about this angle here, which is going to be 360 minus theta. So using this formula, you can find the area of the major sector as 360 minus theta by 360 into pi r squared. That will be the area of this major sector. Suppose you want to find the area of this shaded segment. The area of that segment is going to be area of sector OPRQ minus area of the triangle OPQ. So this is the approach that we use to find the area of the segment. We take the area of the corresponding sector and subtract the area of the triangle. To find the area of the sector, we use the formula theta by 360 into pi r squared. So in this case it's going to be 120 by 360 into pi into 21 squared, because the radius is 21 centimeters. So this expression will give you the area of the sector. Now you need to find area of triangle OPQ. To find the area of the triangle, we usually use concepts from trigonometry. We have drawn the same triangle here. This is triangle OPQ. Let's draw a perpendicular from O to the side PQ. So this is 90 degrees. Let us call this point S. To find the area of triangle OPQ, we need to know the base and the height, so that we can use the formula half BH. We know the radius is 21. This angle is going to be half of 120 degrees, or that's 60 degrees. From right triangle OSQ, we can write cos 60 degrees is OS by OQ. So OS is going to be OQ cos 60, that is 21 into 1 by 2. That's how you find OS. Similarly, you can write sin 60 is equal to SQ by OQ, or SQ is OQ into sin 60. the base of this triangle PQ will be twice SQ, and we know SQ from this equation. To find the area of triangle OPQ, we use the formula half into base into height, half into, take PQ as the base and OS as the height. And we have already found PQ from this equation and OS from here. That is how we find the area of the triangle. When the angle subtended by the chord is 90 degrees, finding the area of the segment becomes easier, because in this case you can directly find the area of triangle OAB as half into 10 into 10, because the two radii are perpendicular to each other. And like in the case of sector, area of the major segment is going to be area of the circle minus area of minor segment. In this chapter you will also have problems involving combination of figures, and the key to solving such problems is identifying the sectors and segments that we need to consider. Sometimes to find the area of a shaded region, it will be easier to find the area of the region that is not shaded. For example, in this question, if you are asked to find the area of the region shaded in blue, it will be easier to find the area of the white region and subtract it from the area of the square ABCD. Each question is unique, and we will be able to identify the right approach to solving a question only through practice. That's all for this chapter. For more revision videos, please like our Facebook page and subscribe to our YouTube channel. Thanks for watching.